Isotopes. Isotopes can be hard for some students. They have a difficult time understanding that neutrons can change, so we're going to try and make sure that you guys are doing okay with this one. The first thing that you need to know, an isotope is just an atom that has a different number of neutrons. That's all it means. So sometimes, for example, hydrogen can have no neutrons or it can have 2 neutrons, and I'll show you a picture of this here in just a second. Because neutrons don't change the identity of the atom itself, the protons are what affect the identity, the neutrons can change all the time, and so we call these different numbers different isotopes. So atoms of the same element with the same number of protons, they can be different in their number of neutrons without changing the atom's identity. They're just a little bit heavier. That's the only difference. So right here I have 3 different hydrogen isotopes. Over here this is hydrogen-1. Whenever you see the name of an element, dash number, that number is its weight. So it's like saying your name dash your weight, and it's a way for us to identify what we're dealing with. So hydrogen-1, because it has 1 proton and no neutrons, has an atomic mass of 1 AMU. So that's hydrogen-1. Over here we have hydrogen-2. It has a mass of 2 AMU because it has 1 neutron and 1 proton together. Notice the number of protons did not change, so it is still hydrogen, but the number of neutrons did. Finally, over here we have hydrogen-3. Hydrogen-3 has 1 proton, 2 neutrons for a total mass of 3, but it is still hydrogen. Even though it weighs 3 times as much, the protons did not change, and so the identity of the atom did not change. So for example, if we take a look at carbon. So carbon-11 is going to have 6 protons every time. Carbon always has 6 protons. But because it has a total mass of 11, we can take 11 minus 6, and we'll know that it has 5 neutrons. Carbon-12 will have 6 neutrons. Carbon-13 will have 7 neutrons, and this can keep going forever. One other thing, we looked at this isotope symbol already, but I want you to look at it again. This is your element symbol. Maybe it's C for carbon, maybe it's O for oxygen. Down here is your atomic number, the number that never changes. It's your number of protons. Up top is your mass number. For this particular element X, we have a mass number of A, which is going to be your number of protons plus your number of neutrons every time.